The direction of up seems to come intuitively to us in our day-to-day lives. But if you think a bit deeper, the meaning of the word and the general direction gets bizarre really soon. Starting off at a human scale, here on Earth, we tend to associate the direction of up as against gravity, and you would probably agree to the same direction of up relative to others in your vicinity, no matter how all of you are oriented. Apart from this definition of up could also be defined as the direction perpendicular to the surface of the Earth, pointed outwards. Or maybe you could define it simply as the opposite of down, down being the direction in which you fall. Whichever way you choose to define it, the direction points in the same way. However, if you begin to zoom out, the direction of up continues to change from person to person the further they are from each other. Someone in New Zealand would actually consider the direction of up to be exactly the same as the direction of down for someone standing in Spain. This is because the direction of gravity is always pointed towards the center of the Earth, and that changes as you move along the globe. So there is no universal up, as the direction itself is relative. However, when we think of the Earth as a whole, we always consider the northern hemisphere to be up and the southern hemisphere to be down. This is because the majority of the habitable land masses reside in the northern hemisphere, implying majority of the human population also resides in the northern hemisphere. So naturally, humans have made maps to show the northern hemisphere to be up. If humans were to have dominated the southern hemisphere in an alternate universe, maps would have been drawn accordingly, with the southern hemisphere on top. Even globes would have been constructed to show the southern hemisphere on top, making this direction of up to be pointed towards the south. Our current maps would appear upside down for people from that universe, yet neither maps could be called incorrect, although one must be upside down. But would we be able to make this distinction out in space? If we were floating near the planet, determining a direction of up for the planet or for ourselves would be a rather tedious task without any reference. Every side would seem the same, and so up would temporarily lose its meaning. Yet, the direction of up would immediately make sense had we been aboard the ISS, where we get a reference based off of the surroundings. We could create a direction of up. This direction of up would be independent of people living back on Earth. Yet, it would make sense to others living in the ISS. But let's zoom out even further. At this scale, we start regaining a meaning of up. This is because the planets of the solar system actually orbit in a single disk or plane called the ecliptic. Most planets stay within 3 degrees of this plane, with a few exceptions, such as Mercury at 7 degrees. This is the reason that all of the planets seem to move about a similar path in the sky, which is known as the zodiac. The reason the planets all end up lying on a single plane is due to the conservation of angular momentum. Although this deserves a video for itself, in short, the planets end up in a single plane because the original gas and debris cloud that the planets formed from were all revolving around the sun. As gravity pulled them together, they had to start spinning faster due to the conservation of angular momentum, which flattened out the debris into a single disk, much like how a fast-spinning ball of dough would flatten out when tossed in the air. Essentially, the balance between the force of gravity and the flattening force due to the rotation, in case of large structures such as the solar system and galaxies, balance out only after they have attained a disk-like appearance. In the case of smaller structures like stars and planets, gravity dominates over the rotational forces, making their structure mostly spherical with a bulge near the equator, forming what's called an oblate spheroid. Even smaller objects like asteroids and comets do not have enough of either, causing them to be irregular in shape. Now, knowing that the plane of the solar system exists, we can assign an up and down perpendicular to the plane. However, which direction is up and which direction is down again becomes solely based on convention. For example, we could consider the side that contains the Earth's North Pole to be up. As you zoom out further into the scale of the Milky Way, the direction of up seems to fade away more to a top and bottom kind of convention, with which one being which becoming indistinguishable from each other. This, however, seems to be the last stage where any kind of up or down can even be assigned. If we were to zoom out further into the cosmos, every direction would appear similar, making it pointless to assign a direction of up. The information about the distribution of energy in the universe can be attained by studying what is known as the CMB, which is the cosmic microwave background. This is the earliest remnants of the universe that was emitted soon after the Big Bang. This CMB is isotropic as far as observations can be made from Earth. This means that it appears to be the same no matter which direction it is being measured from. This hints towards the universe being homogeneous. At large enough scales, the universe will look the same no matter which chunk you choose to see. If our solar system was to teleport to the edge of the observable universe, we would see nothing different but the placements of stars in the sky, forming new constellations in the absence of our known ones. In the grand scheme of the universe, directions lose meaning. Without a reference point, a destination, or a convention, up and down solely become relative, and their existence boils back into yet another man-made construct to help communicate about the world around us. Thank you so much for staying right up to the end of this video. Along with future videos explaining why rotating objects tend to form disks and what form the CMB and how we detect them, PhysiFacts will also be hosting a few hackathons and competitions in the coming year. We highly recommend subscribing as the rate of uploads of videos will be increasing soon. While you wait for newer videos, don't forget to stay updated on Instagram as well. Until next time, stay safe and stay curious.